We are going to work on naming acids and bases. Remember, an acid is anything with a hydrogen in the front of it. So it's anything with a hydrogen in the name. It's going to help you identify what are the acids. There's two general types of acids. Oxyacids, which are acids with an oxygen in it, and these are also going to be ones that have polyatomic ions attached to it. And then we have a binary acid. These are acids with no polyatomic ion. Some general rules in naming acids. The first thing that you want to do is identify if the compound in question has a polyatomic ion or not. Remember, our polyatomic ions are ones with many atoms. Remember, it's the backside of the happy periodic table is pretty much what you're looking for. If you notice, all of those polyatomic ions have an oxygen present, so again, we'll call those acids with the polyatomic ion oxyacids. So if you identify if the compound that you have has a polyatomic ion, you're going to follow the rules to the left where it says yes, there's a polyatomic ion. You're going to follow those rules. So first you're going to identify the ending of your polyatomic ion. So for example, if it has an ate ending, like nitrate, or an ite ending, like nitrite. So you've got to identify the ending of your polyatomic ion. Again, remember, if it's got that oxygen in there, we also call it an oxyacid. If you identify that the polyatomic ion present in the compound has an ate ending, you're going to follow the ate becomes ic rule. So for example, if we have sulfate as our normal ending, we will now end the naming of the acid with an ic. So it would be sulfuric acid. It's also important to note that when we've got naming polyatomics, there's no hydro in front. We don't ever say hydrosulfuric acid. Anytime we've got a polyatomic, it's just the pretty much poly name with the ending changed. So there's no hydro in the name when we're dealing with polyatomic ions. So if I had H2SO4, which is normally hydrogen sulfate, using my knowledge of naming polyatomic ions that are acids, I would create that name as sulfuric acid. The other polyatomic ending is the ite, so you would follow the ite becomes OUS rule. So if we have sulfite as our polyatomic that's within our compound, it would become sulfurous acid. When we're looking at, again, following the rules of naming acids with polyatomic, H2SO3 would be hydrogen sulfite normally, and so it becomes sulfurous acid. And just remember, notice that there is no hydro, or there's no hydrogen in the compound name of acids with polyatomics. We cannot stress that information enough. That will really help you identify what your acid is when you're learning how to do this, whether or not it's a binary or an oxyacid. Now, we're going to look at naming acids that do not have polyatomic ions present, and these are called binary acids. So we're just looking for an H and another element. So when you have H and another element, that's called a binary acid again. I realize that that looks like hand, but that's H and another element, so make sure you're reading that correctly. So again, we call that a binary acid. Remember, bi means two, so it's pretty much two elements present in the compound. So acids without polyatomic ions present have the word hydro in the name. Again, that's a really important marker for you to figure out if you're just listening to the name of an acid, how to identify what's in that compound. So HCl, for example, normally this is hydrogen chloride. So as an acid, we would keep the hydro rather, beginning, and add the ic as the new ending. So it becomes hydrochloric acid, so hydrochloric acid. So now if we look at our naming acid practice, the first thing that we've got to identify is what the normal chemical formula name is, because that helps us with identifying the oxyacid or the binary acid. So in our first example, our normal chemical name would be hydrogen sulfide. And then we're going to figure out if the compound has a polyatomic ion present. So in this case, there is no poly. So now I'm going to follow the rules for naming binary acids. Remember, with binary acids, we have the word hydro in there. So we're going to keep hydro, and we're going to change the "ide" ending of sulfide to "ic", because that's what my rules say for naming binary acids. So it would be hydrosulfuric acid. Pretty easy. So then, naming practice again for the next one, we're going to identify what the normal compound name is. So in this case, it would be hydrogen nitrate. And then we're going to identify if there is a polyatomic ion present in the equation. So I noticed there that there's a polyatomic, so now I'm going to follow my polyatomic ion naming rules. So then I've got to identify my ending of my poly. So in this case, the nitrate has an 8 ending. So now I'm going to change my 8 ending to "ic". So I'm going to drop the hydrogen and change the ending. So it becomes nitric acid. So again, notice that there's no hydro at the beginning of a polyatomic ion acid. Again, also called an oxyacid. So now as you look at the back, that's going to be your practice for what you're doing. So practice naming acids on the top there. That should be relatively easy. Remember, if you're working backwards, try to remember the hydro rule. If it's got hydro in front, you know it's a binary. If it does not have hydro in front, you know it's something with a polyatomic. On the bottom, that's practice naming a base. So remember, a base is a compound with a hydroxide ion present. So I'll do the first one with you. So potassium hydroxide, in order to make our chemical formula, we know we have to write the charges above the words. So if I've got potassium as a +1, I know hydroxide as a -1, I go to make my chemical formula. Very simple, KOH. So then this should be pretty easy practice from last unit when we worked with net ionic equations. But if I split that up into ions, I know I have 1 potassium ion and 1 hydroxide ion. The rest of that will be homework. That's going to be due the next class period.